Okay, this is term 1 week 5 mechanics CA. I'm going to go through it a bit quicker because same as the periodic. If you want to read the notes, they're up on the drive. If you want to watch the course revision, the course revision is already recorded. What is the acceleration between 0 seconds and 2 seconds? A equals velocity final minus velocity initial over time. The final velocity at 2 seconds is 4. The initial velocity is 0, started from rest, over 2 seconds. You get 2. Okay. Here, what is the net displacement? What's the net displacement? It's 28. Let's see. They said net displacement. And here, how do you find the net displacement in a VT graph? You find the area under the graph. Since this is a trapezoid, so base 1 plus base 2 over 2 times the height. Base 1 is 10, base 2 is 4 over 2 times 4 as so 50 times 4, yeah? You get 28. Question 2. Okay, you have a cyclist speeds up from 5 to 25 in 10 seconds. So quickly, let's write this. U equals 5 meters per second since he started at 5, and the final velocity is 25 meters per second. Okay, this is the first thing you write. Okay, since the velocity is changing or since he's accelerating, whatever this is, you write these. And time is 10 seconds. This is for the first phase. Then they said he travels at 25 for another 10 seconds. What is the total distance? When you want the total distance, you have to add up the distances. And in this case, this is UARM. But this one here is not UARM, it's URM because it's a constant velocity 25. And in URM, there's only one formula, and it's x equals vt plus x node. Okay? When solving any UARM question, people did this in the periodic because I told them, how they always told me, Walid, how do I know what formula to use? I always told them this. I told them this technique, and they came to me after the periodic. They told me, thank you. It helped me solve. I swear to God. Okay, so we want to find the distance in two phases. So we want to find the x in this UARM phase, and we want to find the x in this case, which is vt plus x naught. For your UARM phase, this is what you do. You list all you're given. You see 5 meters per second, you quickly write u equals 5 meters per second. You see 25, you write v equals 25. You see 10 seconds, t equals 10 seconds. Then you see what are they asking for. You write, they said distance, so you write x equals question mark. So then you look at your formulas. Your formulas should be written on your scratch paper as soon as you enter the exam. Okay? You write them all down. And in this case, there's no formula that has x, u, v, and t except v squared minus u squared except u, this one, u plus v over 2 times t. This is the equation, the only one that does not have acceleration. Okay, so you're gonna get x equals the initial velocity 5 plus 25 over 2 times the time, which is 10. So you're gonna get 300 meter. But are we done? There's also this phase, the URM phase. And what is the x in the URM phase? It's always the same thing for URM. Vt plus x naught. The velocity is 25. The time is 10. And x node, it's not given, so we just put 0. So it's 250, and I did something wrong. This is 150 here. Yeah, 150. I didn't divide by 2. Anyway, yeah. You get 150 and 250, and we add them up since it's the total, so you get 400. Question 3. The diagram below shows the variation of a cyclist's velocity with respect to the time. What is the total displacement? The total displacement, again, in a VT graph is equal to the area under the graph, right? The area under this graph, it's a triangle. Base is 80. It's BH over 2, right? The base is 80. The height is 6. Divide by 2, you get 240. And these should not take any time. Okay. A runner passes the start line at a speed of 1 meter per second. So he's starting at a speed of 1 meter per second. So what do you write? You write u equal 1 meter per second. And accelerates at a rate of 0.5 meters per second squared. So what do you write? A equals 0.5 meter per second squared. This is how you solve. I'm even showing you the technique of how to solve for 10 seconds. Time equals 10 seconds. Then you see, what do they want? They want the displacement. So what do you write? X equals question mark. What has x, a, t, and u? X equals half a t squared plus u t plus x node. So you're going to get x equals half the acceleration, 0.5, times the time squared, 10 squared, plus the initial velocity 1 times the time, 10. Plus x naught is 0, it's not given. So you get, what do you get here? You get 5, 25, plus 35, yeah. Question 5. A student releases a small steel ball from a height h. The ball hits the table 0.3 seconds later. So, table 0.3 seconds later. T equals 0.3. Given G equals 9.8. So, G is the same as A, which is 9.8. What do they want? The value of h. H, in other words, they're saying x, the displacement x, right? What has x, a, and t? X equals half a t squared. أكيد plus ut plus x node بس نحن we're not gonna write it because we didn't give us u, didn't give us x node, so we don't care about this. So x equals half a t squared. He's releasing it from up. Look, a can be negative, g, sorry, can be negative, can be positive. In two cases. If the ball is coming from up, in this case it's falling down. And g, you know, g is comes from the weight, right? It's the acceleration of the weight. And the weight pulls you down. So if you're following the direction of the weight, yeah, it's positive. But if you have a ball and you throw it up, we know that the weight, W, pulls it down, right? But this ball is going up. So since it's opposing the weight, when it's going up, it's negative. That's just how to know when to put G as negative 9.8 or positive 9.8. Okay, in this case, we're going to keep it positive since it's falling down. Okay, x equals half the acceleration 9.8 times the t squared, 0.3 squared. You get 0.44. Question 6. A body moves along the x-axis. Its position is x equals this, where x is expressed in meters and t in seconds. The initial position of the body is at x0, and what is it? When you have x0, you know, x0 means when t equals 0. So its initial position is when the time equals 0. So 2 times 0 minus 8 times 0 plus 5, which is 5. The initial velocity of the body. Let's see. Now we found this is 5. Initial velocity of the body. Walid, what? How? I don't know. Walid, how am I supposed to get initial velocity if I like, what do I do? Let me show you. Now we said x, derive x, you get v. Derive v, you get a. And I have the expression for x. They said x, this is x. Whenever you have x squared, you can, that means you can derive it, you're able to derive it. When do you use this way of deriving you use this way when you want, like when you don't have anything, like I can literally, no formula here could work. You don't have anything that could work with velocity. You use this, you use derivation when you need an equation for something, but the formula doesn't work. So in this case, why am I telling you derive? Because I want to find velocity, and no formula will work on velocity. So you just derive, okay? So if I want to find initial velocity is when t equals 0. That's what they're trying to say. Anytime you want to find instantaneous velocity, you have to find the expression for v. If they said average velocity, okay, between t equals, I don't know, 2 and t equals 5, you will not derive. Why? Because average velocity is equal to x final minus x initial over time. In this case, what do we need? We need x's. So you use this x here. But here they're not saying average, they're saying at a given instant, they're saying the initial velocity. That's at the instant t equals 0. Whenever you want instantaneous velocity, this was from IG math from last year. You derive the equation. I'm sure most of you know how to derive. You multiply and reduce it by 1. 2 times 2 is 4. So your expression for v of t would be 2 times 2 is 4 t. 1 times minus 8 is minus 8. Where the t goes, because the power of t in this case is 1. Subtract 1 by 1, you get 0. And then the 5, it's a constant number. You know, derivation of a constant number is always 0. So you get the expression for vt is 40 minus 8. Well, they're saying t equals 0, right? Initial velocity and t equals 0. So v 0 equals 4 times 0 minus 8, which is minus 8 meter per second. What is the acceleration of the body? Okay. I just realized you can do this without deriving. Okay. Yeah, you can do this without deriving. Let me see. Hala, you can continue if you want to find acceleration. When they just say acceleration, you know, if you derive v again, you get a. So if you derive 40 minus 8, you get the acceleration is equal to 4. This is completely correct, huh? Because if you multiply the exponent of t by it's 1. So 4 to the power 1 times 4 is 4. If you reduce the exponent by 1, خلاص the t goes, and this 8, you don't derive it. Constant derivation is always 0. You can get 4 like this. But I just realized you can do this, you can solve this by comparison. Okay? We know at UARM, whenever you see squared, we know x equals half a t squared plus u t plus x node. So these are all the answers to ABC. If you compare the coefficient of t squared here and here, you'll get that 2 equals to half a. And if you solve this, you're going to get equal 4. And then if you compare this ut, the coefficient of t with coefficient of t, you get minus 8 equals u. And if you compare the x node with the x node, you get 5 equals x node. This way is completely correct. Okay? I should have given you this way at the start. My bad. But it's still important to know how to drive. Question 7. The speed of a bus traveling south is reduced. Oh my god, this question. Okay, it was in the course practice. So it's reduced from 54 to 36. So u equals 54 kilometer per hour. Let's change this. I don't want to work with this. I want to work it in meter per second. If you want to convert to meter per second, you divide by 3.6. You get 15 meter per second. I don't want kilometer per hour. V كمان, if you divide by 3.6, you get, I think, 10. You get 10 meter per second. So they gave us u and they gave us v in distance of 62.5. So they gave us x equals 62.5 meter. What do they want? Acceleration. How do I find acceleration without time? The only equation, remember, without time is v squared minus u squared equals 2ax. V squared, it's 10 squared, minus u squared minus 15 squared equals 2 times the acceleration, which is, we don't know, times 62.5. Let's see. 10 squared minus 15 squared minus 125 divided by 2 times 62.5 is 125. You get a equals negative 1. Okay? A is negative 1. If the bus keeps decelerating from the same rate, how long will it take to stop? Okay. So, now we know A is equal to negative 1. In this part B here, they're saying it's decelerating at the same rate. So we know A is equal, I'll write it here, A is equal to negative 1. This is a new phase of motion. I'm going to ignore everything here, I'm going to go here. From 54 kilometers per hour, so that means U is 54 kilometers per hour, which is equal to, like we said, we wanted meter per second, 15 meters per second. How long will it take to stop? So we know to stop is another way of saying velocity final, or V equals 0. What do we want? Time. How do we find time if I have V, A, and U? Easiest one, super simple equation, V equal AT plus U. 0 is my final, A is negative 1, T, we don't know it, U is 15. You're gonna get 15 seconds if you solve this here. The distance covered by the bus before coming to a stop. Very easy. نحنا, I'll erase this a bit. We want to find now the distance. Okay, what do we have? It's the same, these are the same, right? We said that A is negative 1. We said that V is equal to 0. We know that U is equal to 15 meter per second, yeah? So we use 54 kilometers per hour. We're using a meter per second. We know that the time now is 15 seconds to stop. How long is the X? The distance. How can I find X if I have everything? Easiest one is, let's say, half AT squared. Can you use half AT squared? Let me see. 0.5 times 225. Yeah, that would work. But you'd get, yeah. Okay, you can use half AT squared, or you could use V squared minus U squared. It's completely fine. Yeah, okay. Let's see, we want X. We can use anything. You can use X equals half AT squared plus UT plus X node. if you get u times t, wait, let me see. 0 point, negative 0.5, negative 0.5 times t squared, 15 squared, plus u, which is 15 times 15. Yeah, you'd get a positive number. Okay, yeah. You're gonna get here half. I was just saying, I was a bit sketched with the answer. I wasn't sure. T squared, 15 squared, plus u, 15 times 15, u times t, plus x node, we don't know, it's just 0, right? In this phase of motion. So you're gonna get, like I did now in the calculator, put this in your calculator, you get 125.5. 112.5. Sure, 125. 112.5. They said to 3 significant figures up, so you put it to 113. Okay, drag and drop the correct phases of motion. This is a VT graph. If velocity is increasing at a constant rate in a straight line, أكيد UARM. If velocity remains constant, أكيد URM. If again velocity is decreasing or changing with a constant rate, again UARM. ماشي. هلا here they're saying the ball was initially at the origin. Was the net displacement? Net displacement in a VT graph. Heidi, you have to find the distance. Well, they broke it up into 3 shapes for you, so let's find it. We're gonna call it x. We're gonna call them 3 phases: xa plus xb plus xc. xa is equal to the base 5 times the height 0.6 divided by 2. You're gonna get 1.5 meter. بعدين x of b, you're gonna get the base 5 times the height, because it's a rectangle, 0.6, which is 3 meter. بعدين x of c, remember, here's the trick part. If part of it is up and the other part is down, you add up the heights. 0.6 plus negative 0.2 is 0.4. So the height of this triangle is 0.4. Times the base 10 and 12, it will be 2. You know, it's base times height divided by 2. You're going to get 0.4. Add these up, you get 4.9. Question 9. A rocket is fired vertically from rest. So, u equals 0, since from rest, and ascends with acceleration of 20, equals 20 meter per second square, for 80 seconds. Time equals 80 seconds. Its fuel is then used up, and then the rocket continues until it stops. G equals 10 meters per second squared. أول شيء, we want to know the first 80 seconds. So we're talking about this phase of motion. What do they want? Altitude. In other words, the height, or x. So this is our first phase of motion. We want x. How do we find x having at and u? Easiest formula. X is half at squared plus ut plus x node, which is equal to half the acceleration, 20 times the time squared, 80 squared, plus the initial velocity, which is 0. We don't care about it. So ut x node, we just put, we don't care. So you put this in a calculator, you're gonna get 64,000. Part B, what's the rocket's speed after 80 seconds? We know you don't need part A for part B. So they want speed, so they want V. So we found x, we got it 64 times 10 to the power of 3. We want now V. Now you have everything, so it's very easy. The easiest formula for me for V is at plus u. Acceleration is 20, the time is 80, the initial velocity is 0. You get 1600 meter per second. What's the maximum altitude reached by the rocket? So we know that the maximum altitude, let's call this phase 1, accelerating phase, and then now there's no more fuel, so it begins to decelerate until it stops. And what's the rate of its deceleration? It's 10. So actually, we call this phase 2 now. We know that its deceleration is g equals negative, the acceleration is equal to negative g, because it's slowing it down, so it's stopping it. So okay, it's negative, which is negative 10. Okay, we know that the velocity, the initial velocity before it started slowing down, is how much? We found it in part B. It sped up until it reaches and started slowing down, right? So 1.6 times 10 to the power of 3 meter per second. What else do we know? We know that it stopped, so its final velocity is 0. Okay, what are we trying to find now? The x. Okay, how do you find x without time? v squared minus u squared equals 2ax. V squared 0. U squared negative 100. Because negative 10 squared is 100 and negative 100 is negative 100. Okay. 2 times the acceleration. Ooh. Lay. What did I just do now? U is not 10. Why am I using 10? It's 1.6 times 10 to the power of 3. So 1.6 times 10 to the power of 3 squared equals 2 times the acceleration negative 10 x. Put it in your calculator, and I want to see if what I'm doing is correct, because Sarah, it looks wrong. You're going to take this 2 times negative 10. You're going to take negative 20 to the other side and divide by negative 20. So you're going to get fraction negative 1.6 times 10 to the power of 3 squared over negative 20. 128,000. طب وليد, isn't this 192,000? ما حبيبي, the maximum altitude مش نحن we reach 64 times 10 to the power of 3 كمان. So you're gonna add 64 times 10 to the power of 3. 192,000. Question 10. A motorcycle moving initially from the origin at 2 meters per second. So u equals 2 meters per second. Moving in the positive direction accelerates at 0.4. So a equals 0.4 meter per second squared. For 60 seconds, time equals 60. No, time doesn't equal 60. You'll see why now. The velocity of the motorcycle at t equals 30 seconds. They want velocity. We want v is question mark. At t equals 30. This is why I didn't try t equals 60, because they're trying to trick you. They put 60 in the question, but they're asking for 30. How do you find it? You have v, you have acceleration time, and u. ما في أحلى من هيك. 2 هيدا 30 و u is 2. So you get what did I أنا سكران guys, سكران. Sorry. AT plus u, acceleration is 0.4. So 0.4 times the time, 2 plus times 2, yeah, times 30. ما بعرف ليش عم بتلخبط أنا. Times 30 plus u2. You're gonna get 14. The average velocity between 0 seconds and 60 seconds. Okay. Whenever you see average velocity, people always get confused. It's a common mistake students make. You have to use final minus initial. You can't just find v. You need to find final minus initial divided by time. Okay? We need final, so at 60 seconds. We're going to find the x at 60 seconds minus the x at 0 seconds. Okay. I think the x, wait, let me see. Yeah, let's see here. So, I'm going to erase this because I don't need it anymore. I'm going to fix this t because it's pissing me off. Okay, this is 60 seconds, akid. So t now is 60 seconds. I want to find now the x at 60. I want to find x. Can I find it? Yes. We have at and u, so x equals half at squared plus ut plus x naught. We don't care about x naught. X, we don't have x naught, that's why. Half times the acceleration 0.4 times the time squared 60 squared plus u, which is 2 times the time. If I'm not wrong, I don't know, I don't even know what I'm saying. 0.5 times 0.4 times 3600, because 60 squared is 3200, that's 120. 840. So x in 60 is divided by time. X at 60 is 840. Minus x0, if you substitute the time as 0 in this equation, akid you're gonna get 0, right? So 0 over the time between 0 and 60 is 60. Divide this by 60, you should get 14. Yes. 12. The acceleration considered to be a straight in a... Okay, they gave us a equals negative 6. They gave us that the initial particle, initially it's at x equals 1, so x node is 1. Moving towards origin at 5. Okay, so this is still part of u. Okay, be careful. They said the positive direction is against the motion. So that means, what is this? It's negative 5 meters per second squared. Right? Since we're moving towards origin, it's negative. What is the average velocity over the first 10 seconds? Again, average velocity, yani x final minus x initial divided by time. Okay, in the first 10 seconds. At 0 seconds, So يعني it's x of 10 minus x node over the time. Can you find it another way? Perhaps I'm doing something wrong. No, that's correct. Okay. At x 10 seconds, we want to find x at 10 seconds, right? We have a, we have u, they said 10 seconds. How do I find if I have at and u and x node? I can do half at squared plus ut plus x node, right? Half at squared plus ut plus x node. So x at 10 seconds is going to be half the acceleration, -6, times the time squared, which is 10 squared, plus the u, which is -5, times the time, which is 10, plus x node, which is 1. Well, I think you should get 314, -349 actually. 5 times -6 times 100 minus 5 times 10 plus 1, -349. So x10 is equal to minus 349. So minus 349 minus x node. X node is 1, so minus 1 over the time, which is 10. You get -35. Okay. Instantaneous velocity at t equals 10 seconds. When you have instantaneous velocity, you can just find v. No need to do final minus divide by time. Let's see. Can I find v in all of this? I have a t u x node اللي بدك إياه. I have it all. So the easiest one always is a t plus u. So we're gonna go down. V equals acceleration, which is -6 times the time, which is 10, plus u, which is -5. You're gonna get -65. How long does the particle remain in the positive side of the origin? Okay, this is the nice part. How long does the particle remain in the positive side of the origin? T is question mark. We know. How far is it from the origin? 1 meter. We know that it's moving towards the origin, right? At 5 meters per second. You know that when we want to find the time between, let's say this is the origin O, and this is where we are now at 1 meter. We're moving like this. We want to find the time of how long it stays on this positive side. Once it reaches the origin O, that means x is equal to 0. So you can just substitute x equals half at squared plus ut plus x node. And what do we know? We know x is equal to 0. With the acceleration, we copy them up from up. -6 time squared, we don't know. U is -5. T again plus x node, which is 1. هيدي بتحلها. Minus 3t squared minus 5t plus 1 equals 0. Or if I'm not wrong, if you put it in equation mode, you should get the correct answer. -3 minus 5 1 0.18 seconds. Okay, the other answer is negative. Yeah, this is rejected. Other than that, ما عادش في شي for tomorrow. Thank you so much for watching and good luck tomorrow.